Anthony, mute your mic. Good. Now, okay, I've muted you, Anthony. So we are starting. Today we are going to talk about emergency lighting. To understand everything. After finishing the emergency lighting, we'll be now going to the last part, which is about designing. Now we will be able to design the lighting points in an installation and in a building, and that will be our last topic. So you should be at this time, you should be reviewing, knowing what to do, what we have done, what we have not done, putting together the questions so that you can ask the questions when you ask the questions when we finish the syllabus. So emergency lighting, what is emergency lighting? If we start with emergency lighting, this is lighting that is normally used during emergencies. During emergencies means when sometimes, let's say, a fire has broken out and light has been put off, has been switched off, and maybe you are trapped in a room and you need to move out. What do? There's normally called something called emergency lighting, or during when you're running for safety. So what do? There are some installations that are normally installed that are not the normal installation, that are meant for emergency functions. So we're going to talk about it now, what is required and how it is designed. Now, learning objectives. What are we going to learn here? We are going to understand where emergency lighting is required in non-residential building as required by codes and standards. We are going to learn about the performance requirements of emergency lighting. We are also going to discuss and comprehend how emergency lighting is implemented and which devices should be used. So emergency lighting is required to illuminate the building areas where the things go wrong. For example, when a normal electrical supply is interrupted by a utility outage or by fire or failure within the building. So in most facilities, the large part of emergency illumination lights and pathways and exists that leads out of the building. So the ingress path, yes, as you get in, you mute your mics. We have just started. We are talking about emergency lighting. Yes. And then we say that its intent is to facilitate the evacuation of the facility, particularly in the event of fire, and to reduce the tendency of occupants to panic under stress and in a desk. So you sometimes you can have you can put into a scenario something like when the Al-Shabaab attacked the Garissa University. They attacked them in the middle of the night, and they made sure that they have switched off all the lights, so they were attacking people. So emergency lighting, the work of emergency lighting is to save that situation. When there is an emergency, when you need to get out of the room, when you are stressed up, you need to get out of the room very fast. So you will have to, any installation must have what is called the emergency lighting. Now, because the performance of emergency lighting is directly related to life safety, codes officials are notoriously damaging of demanding of strict compliance in its design and installation. Now, differing interpretations about emergency lighting requirements easily can lead to a costly delay of occupancy. Now, clear understanding of the code requirements for emergency lighting and a clear understanding of the code officials' views of any issues that admit interpretation will go a long way toward avoiding expensive and embarrassing surprises late in construction. So the term emergency lighting appears frequently in the codes, but it is nowhere directly defined for the purpose of this article. So emergency lighting refers to the lighting equipment that is specifically identified, such as the one in the codes, with limited expectations. Certain lighting that must illuminate under emergency conditions in health care facilities, but is not technically defined as emergency lighting. So we are going to look at this. And after that, we look at how to design. How can we design the emergency lighting, and what are the importance of having the emergency lighting? Now look at that picture. Now this picture, if rendering provides an example of how the emergency lighting system might illuminate a hallway in an office building. Now you can see these are emergency lighting that are there, but they are illuminating the hallway so that when people are exiting, they can be able to run very fast. So this code, the codes are refers to. You can see now this. We have the International Building Code, that is edition 2015. We have the National Electrical Code, that is the NEC, that is 2017 edition. We have the Healthcare Facility Code. Those are the codes that normally govern the design, and we have the standard of emergency and standby power systems code 2016. We have the standard on stored electrical energy in emergency and standby power systems. So the code enforcement agencies may adopt these codes or other codes and may enforce other editions. Provision of various codes sometimes differ regarding similar set of requirements. Designers should verify the codes and editions in force and consult authorities having jurisdiction regarding their interpretation of ambiguous or conflicting requirements before design commences. So emergency ingress lighting and other emergency lighting, what are they and how are they used? So the existential requirement for emergency lighting appear independently in the IBC, and we have already talked about this code, an NFPA section that, meaning the ingress illumination covers lighting requirements for the exit routes. You realize that when we are doing an installation in a building, when we're doing finishes, you'll realize that there are some parts located that exit routes. These are called emergency exits. When in case of any emergency, or in case something has happened and you cannot follow the normal route, you have to follow the emergency exit routes. So it calls for ingress lighting for nearly all occupations, with limited expectations from agricultural and livestock building, dwelling units in institutional occupancies, and most residential occupancies, and sales in assembly occupancies. Ingress lighting must remain active whenever the building is occupied. So under normal conditions, ingress lighting must be served by the building's primary electrical supply. So when the supply fails, the emergency power supply must illuminate specific areas, particularly pathways, and lead to exits and exit themselves and exit discharge. So the IBC allow for a number of options for the form of emergency power system. It may be an on-site generator, a battery-powered system, or a distributed set of batteries attached for individual luminaries. So those are the kinds of luminaries that we are going to use, and the codes. So that code provides a similar set of requirements, that is emergency lighting required for ingress in all the occupancies addressed in the code. So we proceed, look at now that. That is another kind of emergency lighting. A wall-mounted battery-powered incandescent ingress luminary was installed in an elevator lobby in Texas that condominium. The test switch and pilot light can be seen at the bottom of the luminary, courtesy of that. So these are some of the lightings. It is battery powered, meaning when lights goes off, the battery can be able to switch on that light or that incandescent light. So the locations. The NFPA requires emergency ingress lighting exit access at exits and at exit discharge. For this purpose, the term exit access denotes only designated stairs, corridors, ramps, escalators, and passengers way leading to an exit. Exit discharge denotes similar designated building components leading to a public way. So in a typical design project, These building components are designated by the architect and indicated in the life safety plans. When those plans are not available early in the design process, the designer can get very close to compliant egress lighting by providing emergency lighting in their corridors and stairway. So you realize that some of these ways or some of these places where the people can pass. Okay, Humphrey, I'll zoom a bit. But people like Salad were saying that when it is zoomed, they don't see, but I'll zoom a bit so that you can be able to see. So that is it. What if I expand it? Is it okay now? Somebody, Humphrey, unmute your mic and tell me if that is okay for you.
Yeah, mute nini zoom kidogo.
Nikizoom sana, Salad alikuwa ananiambia aoni. Salad, is it okay? I need your response.
Yes, iko sawa kwangu sahi.
Humphrey, na uko sawa?
Yeah.
Sawa, tuendelee. So we are talking about the locations where we engrace the lightings. These are places like the corridors, the stairs, the ramps, the escalators, and the public way, the public pathway. These are the areas where people need to exit in a building. So exit signs are required along the ingress path, at doorways leading to ingress path, and at exits placed to ensure that the exit sign is visible from no more than 1,000 feet of the listed view distance. So these are the codes. This code requires the battery-powered emergency lighting with an average illumination at the floor level of 2 feet at generator sets and at generator parallel gear. So this requirement also is of this. These are just the codes, and the codes you can always be getting them. I gave you an assignment of getting the IE regulation on emergency lighting. I hope you're going to submit it as I have indicated. So we will not cover that because it's already in your assignment. So it's your work to look for the IE regulations for the codes of this emergency lighting. So technically, these lights are not emergency lights, as there is no emergency electrical system defined for healthcare facilities. So the NEC, that is the National Electrical Commission now, Council now allows these lightings units to be connected to a critical branch rather than the life-safe branch. Performance. Now, what is the performance of this emergency lighting? The general performance requirement required for emergency ingress illuminations are shown in the IBC code and this code. So you look for these codes. Illumination requirements are identical in these two codes. The ingress path must be illuminated at an average level of 1 FC with a minimum level of 0.1 FC and the maximum or minimum level of the ratio of that. So that the NFPA code also requires that new emergency lighting power system to be at least type 10 glass 1.5 level system. So those are the requirements of the codes. Now look at that. This is another kind of emergency lighting. This is a battery powered fluorescent lumina in an office corridor. Shows the test switch and pilot light. It incorporates a battery ballast which illuminates one of the 3 fluorescent tubes which when power fails, courtesy of that. So that is a company that prepares the emergency lighting lights. So you can see those fluorescent tubes are there, but it is powered using a battery. It is not powered using the normal electricity. So it is a good thing. And then we have the testing. How do we test? The testing requirements for emergency lighting appear in this code again. The lamps are powered source must be periodically tested to verify that they continue to function in accordance with the code requirements. So all the emergency lighting systems, regardless of their power sources, must be tested monthly for a period of at least 30 seconds. For unit equipment, monthly testing typically consists of the shortest test of the battery and lamp implemented by the test switch on the Lumina. Then for storage battery, the generator system, testing is typically accomplished by de-energizing the normal power source, serving emergency lighting, and observing that the lamps illuminate. You make sure that after installation, you have to test the system and make sure that they are working. Now, like for example, this exit, it has a lamp that is attached below it, and any switching, and the moment you press the lighting, it will work. So the generator systems must be tested monthly by initiation at a transfer switch and run under a load of at least 30 minutes. Emergency lighting tests are normally performed in conjunction with monthly standby power system tests. So for conditions with emergency lighting test, it would be convenient to initiate monthly generator tests from the emergency system transfer switch. However, the NFPA 110 requires that the transfer switch initiating the test be rotated among switches from 1 month to another. So the storage battery system are required to be tested in accordance with the manufacturer's recommendation rather than in accordance with the code mandated schedule. So this photo is of a luminescent exit sign. So you can see this picture, it illuminates by itself, it shines, and by shining it provides light to be able to exit and the place of the floor. Now this sign was installed after the occupancy in response to the new code requirements calling for exit signs near the floor. So you can see that one, courtesy of that still. So what about the electrical system? Now the electrical system of the emergency lighting. The installation requirements for power systems serving emergency loads, including emergency lighting, appear in this code, the NCE Article 700, emergency system. So the power sources permitted under the IBC storage battery system, on-site generators and unit equipment also are permitted under the Article 700, along with fuel cell systems per that code. So a separate utility service may serve at the alternate source where its reliability is acceptable at the AHJ as per that. So should be consulted in advance of construction where a fuel cell system or alternative system is contemplated as the emergency supply. So the electrical supply must provide power within 10 seconds of the loss of the normal power. You can see there. Article 700 requires strict separation of the emergency system wiring from all other wiring. You have to keep in mind that the emergency system wiring is not incorporated in the normal wiring, so they are different. So being at separate vertical switchboard section or disconnect switch are connected to the emergency supply. Okay. So we have also the electric supply must provide power within 10 seconds of the loss of the normal power. What about the overcurrent devices? These are the overcurrent protection devices that are normally used. What happens to them? The overcurrent devices on the emergency power supply must be selectively coordinated with all upstream devices. So the definition of selective coordination in the NCE code is quite strict, requiring coordination of the full range of current settings and device operating times. So achieving selective coordination with current circuit breakers will require careful device selection, otherwise fuses must be used. So emergency system feeders and generator control circuits must be protected from the fire by one of the several methods. Equipment serving emergency feeders must be protected by either the automatic fire suppression system of a 2-hour rated enclosure. A special occupancies, that is like healthcare. Now, what happens to emergency lighting in special occupancies? Now, this article modifies certain requirements of emergency system in healthcare facilities. So those documents do not define an emergency electrical system. Instead, they define an essential electrical system consists of a life safety branch, that is the critical branch and equipment branch. So the emergency ingress lighting is served by the life safety branch and other lighting that must remain operative to provide patient care and support necessary for hospital functions served by the critical branch. So we go on and say the hardware. Now the hardware is the outlook, the things that are used in installing or in bringing up these exit signs or the emergency lighting systems. So now we have the NFPA is a code 101, and the IBC permit the use of internally illuminated exit signs. We have talked about the exit signs now, like the ones that I showed you in that picture. Those signs illuminate themselves and they just light, they glow in dark areas so that they can be able to show exit. A good example is those signs or those lower signs in vehicles. When you look at vehicles at the back of the vehicle, they normally have some signs there. Those signs, they are signs that are used they illuminate, meaning they shine in the dark, or when some light bounces on it, they shine back. So they are able, so you are able to see or to notice that there's something on that way or there's something in front. Photoilluminescent materials absorb light from incandescent light and slowly release the energy as visible light. So energy is stored in the electrons cloud surrounding the individual atoms of the photoilluminant material. So in that incident light knocks controls into elevated energy states. So as those electrons return to lower energy states, they release their stored energy as visible light. There's another one called on a macroscopic scale. These materials behave as light batteries charged by incandescent lights and discharged with darker environments. So these materials are applied as letters in the exit signs, like the one we saw. So where they glow to make the ingress path in low illumination. Another material that is used out of the hardware is the photoilluminescent signs have long usable life and require little maintenance. We talked about the photoilluminescent the exit signs or the materials, that the hardware that it involves. The units are typically warranted for 15 to 25 years. So the primary maintenance method is to clean the face of the signs, as obstruction of the face will directly reduce the light output. The exit sign must also be continuously illuminated by a minimum level under normal conditions, typically 5 FCS, to remain charged. So as the energy codes become more restrictive, requiring occupant sensing, daylight controls, and control of ingress lighting. So for the luminescent materials are generally charged by light in the upper end of the visible light spectrum and the low end of the ultraviolet region. So you can now see that other kind of lighting. These are concealed articulatory emergency lumina shown in an open position. This lumina is considered unit equipment with a battery contained within its housing. Now you can see this is another kind of emergency lighting that has a battery. It is lit using a battery. It is lit using a battery there. Now another hardware unit equipment, that is the unit equipment in electrical item used to describe the battery powered lighting unit, is described in that code. I've already told you that you look at the codes later. Consisting of a rechargeable battery, a battery charger, provisions for connecting attached or remote lamps, and means of powering lamps from the battery when the normal supply is unavailable. So the term covers both illumination fixtures and exit signs. So unit and exit signs. Unit equipment may illuminate with the facility normal lighting and switch to battery power under emergency conditions, or it may operate only when the normal supply fails. So that is the last slide in that presentation. I'm going to bring up another. Demands on construction of emergency lighting. Now, what are some of the things needed, or what are some of the requirements for the emergency lighting? What do we need to do? Now, arrangement of distribution circuit cables and wires, emergency lighting system. These are some of the things that are needed to do. After this, we are going to talk about the design system. So installation of emergency lighting system and the summary. So the power supply for all applications from the mains will be warranted. Nevertheless, failures of the mains may occur. So if by failure of the mains voltage, human life or material asset is endangered, then the emergency lighting system may be installed. So it is important to install this emergency lighting system. So emergency lighting is an additional illumination being automatically switched on in case of failure or dimming of the general lighting. So for this additional investment in electrical devices, cables, and installation materials will be required. The power supply for minor emergency lighting system is made by direct current or originating accumulators in normal operations. The accumulators are being charged by the mains via the charging rectifiers. So for emergency current supply of industrial shops, agricultural breeding and hatching plants, protection rooms or operating theaters, the capacity of the accumulators is too low. So emergency current in such instant will be supplied by the emergency power generating sets with a diesel engine. So these have an almost unlimited application and may be suited for the required voltage. So you realize that this emergency lighting is normally not powered using the normal electricity. It must have a battery or a backup generator which gets in automatically. So the emergency lighting system are divided into panic lighting and the special lighting. We have two kinds of lighting. So the panic lighting illuminates the room and evacuation paths. In case of danger, it will enable escape from the corresponding location without accident or danger. Its mean illuminance will be less than that of the general lighting in an average. In average, it will be 1 to 3% of the general lighting illuminance. So depending on the types of rooms, it is fixed in regulations. This is fixed in regulations. And then examples for application of panic lighting are meeting rooms. These are where it can be used. Meeting rooms, escapeways, stairways, doors in dimmed rooms of public building, outpatient departments, shopping centers, multi-story dwelling houses, museums, restaurants, schools, and production rooms. Contrary of the panic, contrary of the panic lighting, a special lighting will render it possible to continue the processes of interpretation of which would endanger human life. So domestic stock or important plans. So illuminance of special lighting may be up to 100% of the general lighting. That is now the special lighting. Application of field of special lighting, we have places like operation in hospitals, that is theaters, control stations and industrial plants, and information centers and mail trafficking and telecommunication. So demand and construction of emergency lighting systems. Emergency lighting is switched on a prepared or operation for operation by one action of the emergency. So lighting main distribution. In case of the mains failure or decrease of the mains voltage, below a value of 80%, it will switch automatically in the standby. So in case of emergency lighting is permanent, the circuit arrangements are same operates in a parallel with the general lighting. So the changeover of the general to emergency lighting takes place automatically. The changeover is being indicated by optional acoustic signs at the appropriate places at the distribution of the emergency lighting system. The mode of action of permanent circuit arrangement, going to see it. I think there are some pictures that I put there. It's like they didn't upload, but I'll upload the document again so that you can be able to see. So the general power generating sets will be put in operation by an automatic starter and be able to, no dependent emergency lighting. There are pictures that are supposed to be there. This type of emergency lighting will be installed in such rooms which are rarely entered by persons, but which must be lighted also in case of emergency. So the peculiarity of this type of emergency lighting is the action of the general lighting the emergency. So arrangement and distribution of the circuit cables and wiring diagrams of the lighting. For installation of emergency lighting system, a lot of principles in designing of the emergency lighting system are to be considered. The designer will have to include these principles into his working documents for the erection staff. These are the first of all. You install the materials to be used. You choose the type of installation and arrangement of the emergency system, and then the lighting fittings, and then the arrangement of the emergency lighting system circuits is done, and then distribution of emergency lightings will be arranged according to the fire section. For if the emergency lighting distribution is in one fire section should fail due to fire, it will be warranted thereby that the emergency lighting continues to function in other fire sections. For avoiding unauthorized interferences in emergency lighting distribution, these distributions must be locked to make work easier when carrying out maintenance and repair of work. General diagrams. So the general wiring diagram is to include the following information. Now, like the description of the distribution of the details of the last distribution fuse, the current type and supply voltage, the type of capacity. These are some of the requirements or the things that are involved in the circuit. We have the designation of the outing circuits, rating currents of the fuses, number of lightings, capacity and individual circuits. Then we have the cross-section and material of the conductors. So a number of demands are put to the installation emergency lighting lamps mentioned in the following. Emergency lighting lamps may be accommodated together with the general lighting lamps in one lighting fitting. So for being able to design emergency lighting lamps from general lighting lamps and lamp bases of emergency lighting lamps are painted red. So that is what we are going to go through until you read that. The marking of emergency lighting fitting, those diagrams should be there. Normal now for operating emergency lighting system, rated voltages have been established. They may be taken from the table this below. So 12 volt is the system up to 200 watts consumers installation only. 24 volts is for lamps in operation theaters only. 60 volts is for industrial control, not for emergency power plants serving as emergency lighting. 110 volts is power distribution system on remote control stations. 220 volts is preferred voltage enabling a simple and economic construction. Yes, Duncan, mute your mic.
Yes.
Mute your mic. Okay, I've muted you. Just listen. 380 volts application for special lighting only since consumers installation with great capacity are being operated. So installation of the emergency lighting and the summary. The summary now is the emergency lighting is an illumination to be installed in additional investment turning or automatically on is in case of a general lighting failure or too high under voltage. So the supply of emergency current may take place by batteries of emergency power generations. And then the emergency lighting system may be operated as standby circuit or as permanent circuit. It will also be possible to operate the emergency lighting as an illumination dependent on the switching conditions of the system. So I want us to ask some few questions before we break into a discussion. Then when we come back, we are going to go into now the designing. How do we design? How do we design the emergency lighting? We are going to get into the design of the emergency lighting. And before we go there, I want us to have a few questions before we can break for a discussion. Some 1, 2, 3 questions I am picking. And mute your mic so that you can talk. Yes, Duncan, ask something. You are muting again. Edgar.
Yes.
Say something.
I'm satisfied.
You're okay. Yes, Salad.
Yes, madam, hiyo notes ziko mi kwangu zishiki vizuri. Kuna vile zishiki
Ziko?
vizuri. Kuna vile zishiki vizuri hiyo notes.
Hauzioni vizuri?
Hapana, ziko wide sana. Ziko wide.
Ziko wide?
Sasa unaona short notes ndo unaweza fahamu na kushika haraka. Sasa iko wide.
Sasa unajua nini, Hassan? That's why nina explain so that wakati nina explain unaweza uka make down short notes, but still nimewapea, mtasoma baadaye so that you pick the short things that you need from it. Si ni sawa?
Sawa.
Kasheru, nataka maswali kabla tuende for discussion. We are going to discuss there for the next 40 minutes. So by 12:40 we will be back so that we can finish the last part. I need questions.
Yes, madam, niko na swali.
Yes.
Ukiangalia kwa hizi ceilings za saa hii, hizi modern ceilings, zinainstoliwanga na lights. Hizo lights ni emergency lights ama ni za decoration?
Zinainstoliwa na lights. Like now the downlighters zenye huwa tunaona ama nini?
Yeah.
Hizo lights sio specifically at an emergency lighting. Most of the lights zenye zinatumika these days they are modern lights. Ni kama hizo the downlighters. The downlighters. Sasa zikiinstoliwa, not all buildings by the way normally have emergency lightings, but building like for institutions like now for example our university, we need emergency lighting because unajua ni place yenye ina handle a lot of people and panic can come in case of an emergency, in case of an attack or in case of a fire outbreak. There has to be emergency lighting. Si lazima ati iwekwe on emergency lighting zikiwekwa kwa building, they must be put in places where somebody can be able to notice and recognize that these are emergency. So not all the lights that are done in ceilings are emergency lightings. Sawa, Edgar?
Okay.
Another question. Peter,
Yes.
sema kitu.
Madam, hizi note najua kwa simu haionekani yenye una display hapo.
Auoni kitu kabisa? Ama zinakaa kidogo?
Ya zinaonekana but ina strain, as in saa mtu itabidi strain sana ndio aione vizuri.
Na nikiweka hivyo unaona?
Bado labda zoom.
Nikizoom, unajua nilikuanga nina zoom but watu wakaanza kucomplain that hawaoni. So nikizoom na nisongeshe hivi tunasoma kidogo kidogo tunasonga. Is that okay?
Yes.
Salad,
Yes.
wewe ndio unakuanga na shida na kuzoom. Nikizoom na ninasongesha kidogo tunasoma. Will that be okay with you?
Sawa. Utazoom, usizoom mahali moja, zoom zote page moja hivyo.
Ukizoom page moja, unajua I'm using my phone. I'm using my phone to do the teaching. So the phone cannot have a big screen. So ingekuwa kwa computer mngekuwa mnaona vizuri, but my computer haiwezi ka communicate the audio. So that's why I'm using my phone. So just bear with me.
Okay.
See, but the good thing is after tumemaliza class, si mnapata notes kwa portal.
Yes.
Salad.
Yes, yes.
Si ndio mkipata huko saa mnaweza zipata huko. So wakati ninafunza, just allow me to zoom and then so that kila mtu aone. See, that is okay.
Yeah.
Yeah.
Sir, any other question? I want us to go to the discussion. And when we go to the discussion, everybody must participate there. I'm going to post some questions. And before I forget, I've already posted the assignment. Sijui kama mmeona assignment kwa portal. And I've already put the end dates there to submit. Make sure that you submit the assignment in time. And a week after next week, we'll be doing our cut. Na cut yenye mtafanya online. You will be timed. It will be a 1 hour cut. So get prepared with hizo vitu tumesoma zote. Nitawasetia cut. It will be like a mini exam. We are training you guys of how to do the exams online. So tutafanya cut. Na hiyo cut tukifanya, attendance in your cut ni very important. Na pia kama haujakuwa ukiattend, if you've not met 75%, you might be barred from the system. Inaweza ikakukataza kuaccess cut. So ni vizuri kuattend. Sometimes hata unaweza pata umeingia late, na ukiingia late, you can compensate by contributing